So the first thing that you want to say is scientists give feedback. So sometimes a scientist may not use the proper way of, or the best way of analyzing data, which can skew things over, or the best way of conducting the experiment, which can skew things over. That's a good time to check it inside the paper, or maybe the paper. It's like little things as well, where like the paper isn't written well, or the paper isn't written in a way that that is clear to what the end goal of the experiment or the end goal of the theory was. And then the second thing that you'd want to say is peer reviewed is important to make sure that things are reproducible. Like we said, we want to know if cloning exists. Okay, so then calculate the average of one atom of neon. Neon. Okay, so with the neon, with one atom of neon, what we want to do is we want to add up the mass numbers. Okay, so we know that our relative formula mass of neon is 20.2, and then we would want to divide this by Avogadro's constant, which they so kindly give to us, 6.02 times 10 to the power of 23, not minus 23 like I used to think when I was younger, 3.555 times by 10 to the minus 23, and then you're going to have 3.36 times 10 to the minus 23, because what does it ask you, my dear fellas? It asks you three significant figures, so that's what you'd want to write down. And I don't do it, but you always write down inside here, otherwise you might not get the mark for all your great working out. So yeah, don't risk it. Okay, now we're on I. No, I. Two I's. Caramba. Alright, so how many neutrons does an atom of neon 21 contain? So this is neon 21. Now we know that 21 on the top, that's going to be your mass number. What's the mass number? Mass number